Right, hi guys. Sorry, I'm back again. We just had a little bit of a camera thing there. I was just trying to get it sorted. The actual live was actually the wrong way around. So just to start again a little bit. So as you'll see, we're at the STIQ Robotics event today. We have a lineup of panel and lineup of speakers, and the idea is obviously to learn a little bit more about robotics. I'm hosting it today, obviously through my channel. This is a live, and what we'll do through the live is obviously this is just the free going, and then I'm going to cut it up a little bit later on so it all makes sense and all flows. You're gonna have to bear with me 1 second just to make sure that this is actually working and it's working correctly. Give me 1 second. Yeah, and the idea of the live is that you can also ask some questions as well. So what I'll do is I'm going to do some questions to some of the speakers afterwards. And then hopefully if you are in the chat, if anyone wants to chat and ask questions to the speakers, then just let me know. Just give me 1 second just to make sure this is actually working. Right, okay. Some of the speakers afterwards. Right. And then hopefully if you're right, so perfect. So the live is actually working. The angle, the camera is the right way up. So what I'm going to do is I'm going to wait until 6 for the actual thing to start. And then basically we're going to go through some speakers. I'll go through the speakers again, just so we can have a bit of a refresh. So if I turn the camera here, so again, we've got Thomas, who's the organizer. So he's organizing today. We've got Obi, who's going to be on the panel, Mark from CMR Surgical, Obi from Hellermanton, Caroline from DSIT, and Marcus from Dexterity. And then we have the presenters and speakers later on as well from Signal Up from that side. So, yeah, just get ready for the event. And yeah, any questions, throw them in the chat. And again, I'll try to make a nice cut up afterwards to make sure that it all works well. So with that saying, I'm just going to split the camera that way, and then I'll play with that later on. And then I'm just going to play a little bit of music where we're going to start at 6 o'clock. So thanks, guys. Bear with me. Okay, right, so we're nearly there. We got 10 minutes. Oh, and I've messed up my own video. Can everyone see that? I'll just have a look on the chat in a minute. So yeah, 10 minutes to go. We're at STIQ Robotics event. And the idea is really, this is just a live stream for anyone who can't make the event. Anyone who can't come down here, then obviously we can stream it and you get a chance to see the speakers. I have got a chat facility and I'm just going to test it out. Just bear with me for a second. I've got to keep checking these things to make sure they keep working. Let me just log in. Yeah, so there is a chat facility on the actual, whether you're watching this on YouTube or LinkedIn or Facebook. Is the sound working? Why can't I hear anything? Okay, give me 1 second. I know. Test. I hope you can hear that. Let me just do a second test and we'll be with you. So 10 minutes, 5 minutes, and we'll start up with the panel. Test. 1, 2, 3. Cool. Test. Okay. Okay, guys, we are nearly there. We're 5 minutes away. And again, we're going to have the panel up to start with. We're going to start to have people to come in and then we're going to start to get going. So I'm going to set this up so you guys obviously can be able to see the panel speakers. And then we're going to have the interview speakers as well. So we're going to get that all set up and ready to go. So hopefully this is all working and you can hear me. If you can't hear me, then just let me know in the chat. And then we'll start to get ready. So I'm going to put it on mute now and we give us another 4 or 5 minutes. Thanks, guys. Okay, quick sound check. Quick sound check. 1, 2, 3. 1, 2, 3.
It's a robot. It's a robot for dementia. But he also and it's very
You guys
I got it. So this is my question. I'll be up here.
Calm down a little bit. Find a seat. Yeah, we have to come over here. All right.
Yeah, I know.
Yeah.
Okay, let's kick off so we get this.
I suppose you can sit on it.
So, my name is Tom. I'm the organizer of these events. I work for STIQ, which is a publisher of robotics reports. We interview people from across the globe. The reason why we started these events was that we never interviewed anyone from the UK, occasionally a couple, but that was probably the only company. So we set up these events to kind of encourage more of the robotics thing happening in the UK from grassroots up and so on as well. So I see that's loads of interest in our events. So yeah, network and enjoy. On a little note first, in all of these events, we invite about 20 students or so. So don't complain to me later that there are too many students, because it's free to be here and you get free food, you get fed as well. Just make sure that you, some more experienced people should really network with the students. They are the next talents coming up in the industry as well. So we really like to have them with us and that they get a bit of flavor for industry work and so on as well. Yeah. So with that, I will just highlight that we have this report coming up soon. And if you're really interested in the future of warehouse automation, robotics, even a bit of humanoids, you should go onto our website and pre-order this report. With that, we go over to the panel. So, you have these microphones, then we can share it. On. Okay, you can share there as well. So, I thought we'd start with a few intros. So if we start with Caroline first from
Yeah, sure. Hi, everyone. So I'm Caroline France, and I lead robotics and autonomous systems and advanced materials policy at the Department for Science, Innovation and Technology in the UK government. So it's part of a wider team looking after different tech sectors, what we could do to support the innovation ecosystem and the sectors throughout in the UK.
Hello, I'm Marcus. I'm the head of autonomy at STIQ. We are a company that does something I think. We are in the logistics space and we try to help the customer to get their inventory right. Actually, we don't try, but we achieve that.
Hi, I'm Mark Swank. I'm a lapsed surgeon. I used to be an academic in Cambridge. Got concerned about the poor surgical uptake of minimal access or keyhole surgery, so made the stupid mistake of trying to design my own robot. And if I'd known then what I know now, I would never start.
Amazing. Hi everyone, good evening. My name is Obi Joku. I'm the head of automation at Headland Titan. For the last 10 years, I've been working in warehouse automation, factory automation, in places like Amazon, Pepsi, THG. So I sort of cut my teeth in figuring out this game of automation. I went to uni in Cambridge, so I am Cambridge students. Hello. So yeah, that's also a good nod to Cambridge. So yeah, I look forward to this discussion. I think what you get from me is very honest. That's your time in Nigeria, I'm just telling exactly what it is. No, for guys in the industry. So yeah, looking forward to this.
Okay, excellent. So let's kick this off. As you all know, we only have half an hour, so yeah, stay within the time. So, Obi, you obviously at the production end of robotics. How do you view the UK robotics or warehouse automation space today? Is it mainly system integrators, or is it people who make robots? And what do they do better, perhaps?
Okay, so what I see the system now is in the UK, it's a very high labor wage country. Right? So it's very expensive to hire a British man compared to parts of Eastern Europe and the rest of the world. And you would expect that, like, for such a high wage country, we're adopting automation much faster. But in reality, what we see is actually the flip side, right? So places like Poland, Romania, Eastern Europe are catching up way faster and adopting robotics faster. So the way I see the UK market is something like almost like a British culture of analysis paralysis. You think too much about it, trying to evaluate the cost. You can't actually just pilot it out and see if it works and then roll it out. So although the numbers will say, you know, UK automation is growing, I see much faster automation outside Europe, and when it comes to sort of influence the culture here with systematic processes and ways that we can actually adopt automation more faster than we're doing it today.
Very interesting. So over to Mark. As a co-founder of a robotics company in the UK, what is your view on the ease or lack thereof of operating in the UK? I'm aware that you have some strong views on this, so perhaps condense it.
Yeah, I mean, it's quite extraordinary. We've got so much amazing technology in Cambridge, in the country. I went to a meeting with the Cambridge Independent newspaper. We won an award and had to go along and collect it. That's a tiny, small domestic newspaper. It was like a Nobel Prize ceremony. What's going on in the city? You know, to me, why are we not promoting it more? Why are we not supporting these things more? Not just my company, all the others. Cambridge is a unique ecosystem. We hear about the Cambridge-Oxford corridor and so on. But in truth, so far we've done everything ourselves. So we've got unicorn status. We are the second largest soft tissue robot company in the world now. We've beaten J&J to, they started 2 years ahead of us. We've done 50,000 patients. They've done more than a few, I gather. And I just don't understand why the UK doesn't set up a business development unit that actually supports and promotes British companies, because you certainly have the expertise. I almost certainly could not have built my company in many towns other than somewhere like Cambridge, because I needed so much firepower intellectually.
Interesting. Obviously, we have Caroline here. As the head of robotics for the DSIT, how do you view the current state of the UK robotics ecosystem?
Yeah, sure. So I guess firstly on the R&D side, so we did some internal analysis, and the field citation industry across the UK is first in R&D, which is really impressive. We've also got, that's backed up by a number of different innovation centres across the UK, so the National Robotharium in Edinburgh, Bristol Robotics Lab, all of the catapult centres and the various robotics initiatives that they have, the Agri-Tech Centre. There's so much going on that site. There's also then, we identified over 2,000 companies operating in the UK in robotics autonomous systems at the moment, so that's really healthy. We have a number of companies have reached sort of the scale phase, including that who's sitting next to me at the moment. I think, having said that, we're aware that lots of companies struggle to commercialise, bridge the value debt, and then scale up, and that's something that we're looking into and thinking about how we can support those companies better. We're also, as we mentioned, we also like on the adoption side as well. So that's another thing that we have program around, seeing how we can accelerate the adoption, which will have also hopefully support the supply side as well. I think lastly, we're really aware of the massive global investment that's going into this area at the minute, particularly in the US and China, and sort of thinking about, well, what is sort of the UK play in terms of general purpose robotics into the future, and where can we, where are we able to lead in that space as well?
Very interesting. So, Marcus, so let's jump into a bit more technical aspects perhaps. From your perspective as head of autonomy, what does autonomy actually mean in practice?
No easy questions. I mean, for us, it definitely means that we can, without augmenting or changing the environment at all, plug a robot into a socket and let it do its job without us interfering. And that's actually also what we are doing. So we don't need anything from the customer. We just go to a warehouse. We need less than a week to install it. And most of the time, it's about asking and getting the network done. And when the robot is there, it will just do the job. Having said that, there are surprises. So humans are always full of surprises, and they bring our robot in some very, very unique situations. We haven't figured them, so there's still some level of autonomy which we have to, especially when it comes to being adaptive while you have to, being adaptive to a changing environment and how you can fix that.
Yep, it's not for you.
Oh, very accepted. So, yeah, that's it.
Very interesting. So, if we jump back to Obi at the front end of robotics, where they buy and deploy and so on as well, do you think that there are any particular robot types or any type of robots that startups in the audience perhaps should focus on, or even the more legacy companies as well?
Okay, so the way I approach this question is an advice to you. If you ever meet a consultant or some guy helping you with automation, and he starts off by telling you the technology, fire him. Don't, right? Because the answer to that question is based on your problem, right? What problem are you trying to solve? What is the constraint? Is it cost? Is it land? Is it throughput? Is it accuracy? What is the constraint, right? So before I suggest to you, what technology you should pick up, we need to understand your problem. That said, right, there are few standard technologies, back on tested, tried, proven. You don't have to reinvent the wheel. Very popular now is AGV AMRs. One of the it's huge, it's growing, right? It helps move things from A to B. Every single time you move something from A to B, it's a non-value added move, right? It's waste. Right? So at some point, you need to get that waste out of the process. HVM is typically one of the technologies. There are other technologies, conveyors, for example, will do the same job. So you always have to work it out, right? Depending on where you are, whether it's a factory or a warehouse, you would think about things about quality inspection. So vision inspection is a simple no-brainer. If you're about to do high volume, high manufacturing things, if you're moving a lot of throughput, you need these fast vision inspection systems, whether it's to catch the sand on a label pallet or whether it's to catch a quality problem in a production line. So I'll say, those two technologies, bulk, standard, simple, those problems will always exist in your process. And those are some low-hanging fruits that you can, pitch into vision inspection systems. We're running 50 to 100K, AGVM is running 100 to 150K per unit. So again, low entry point. Now, this bigger stuff, ASRS systems, automatic trailer loading systems, automatic layer picking systems, standardized, but again, needs to be specific to your problem. So I'll leave it there, those two technologies, vision inspection and AGVM.
So I hope everybody knows what AG and AMR is, but I will tell you it's mobile robots, just to make sure. Back to Marcus really quickly. What's your view on how far we are away from dark warehouses?
You mean like no connection whatsoever?
No people, or very few people.
I think that's an interesting one, and it actually keeps us awake because we currently don't really have a competition. So you must say you have this for robots that goes around. I will present this later, but millions of locations you can, and there's no competition really currently tackling this. But obviously, people ask us like, why don't we do a full automated warehouse? And that's fair. But actually, what I experienced, even with customers that have almost perfectly unique boxes, like the automotive industry, which has everything pre-designed, even they are not able to fully automate everything because there are surprises, there are deliveries coming in different shapes, and you have to be adaptive. So I think we are actually quite a bit away if we see adaptability to keep logistics running. I don't see it coming early, and to be fair, I also hope it's not too early because I really like what I'm doing. But 10, 20 years maybe, but I don't see really how to solve this properly.
Interesting. So when you deploy robots, safety is obviously critical, and no less so in surgical robots. How do you find acceptance, Mark, within NHS and other hospitals for surgical robots?
The people actually love robots. I mean, if you do a surgical trial now and it's a robot versus something else, you have to design it because otherwise all the patients want the robot. It's an idea they've got. But listening to you, that scares the hell out of me because if you can't automate a factory, how the hell are you going to automate surgical things? Every time you breathe, your organs all move in a different pattern. You all have different anatomy. There's not a standard pattern. Having said that, 3 years ago, if you'd asked me about autonomous surgery, I would have said never ever. I don't say that anymore. I think it's a matter of time till we get certain stages of it. So it will be like an assistance. Can't really automate cars on roads which are stable. You have to think about the challenge with robots. However, 90% of surgery, complicated surgery in the world, occurs in geographies that serve 10% of the world's population. So if we're going to serve the world, we will not be able to train that many doctors. So we have to think about robotics as a potential solution for low and middle income countries. And I'm doing quite a lot of work in that arena.
So what's your answer to the prediction when you have full autonomous surgical robots?
I think full autonomous, I certainly wouldn't accept it. But it's a funny thing. People, when we were starting the robots, my engineers are, they're pretty straightforward. They said, this instrument's got a 2 millimeter chance of unexpected motion. I said, that's not a danger in the body. I said, the doctors came with 18 centimeters of unintended
If I can just get into this conversation and bring a third dimension in it. So the question is to get freeze better to in what geography, right? In the UK, yeah, good luck, right? 10 years away, regulation. Actually, I've just come back from China. I've been on a trip to China, Singapore, and India. And I actually did see a 95% automated factory, right? Look, the Chinese are better. They got it on lock. It's there. It's working fast, right? And we're benchmarking against it's possible, right? It's here already. It's just adoption, regulation. Why can't I do this in the UK? Why is it so very expensive? Why? I keep meeting the same issue. But I spent 2 weeks in China and I couldn't believe it. You can see it. They've automated 95% of the line. Right? Maybe inbound and outbound is left, that's it, because they want to manage by exceptions. But they're not 5-10 years away from this. They can do this next year. So again, it brings back to the point. Why is adoption so slow in a market where the costs are so high? What is blocking it? Is this a cultural thing? Is this a regulation? What the hell is blocking our adoption of technologies that are already there? And it's great mention of automotive because BMW, Mercedes, all these guys, they have factories out in China. BYD is completely taking these guys out, right? They have automated factories. They have to know how. What's stopping the adoption of the copy paste from their plants in India, China, and landing it in Europe? What is blocking it? I don't know the answer to that question. It's what I've been trying to figure out over the last decade in my career, but we'll keep pushing until we break it and just get this thing done.
And just saying, so I agree with the situation here, and the last 5% will be the decisive hit, which we can still win, right? Just to motivate everybody here.
Yeah, absolutely. Yeah. So, by the way, there's one seat here for anyone. Lucas can take now. Caroline, in general, so what initiatives have you got going right now or in the near future that companies or startups in the audience should apply for?
Yeah, sure. So, firstly, building on the discussion just now, our big sort of flagship program, FDSA is the Robotics Adoption Hub program that was announced as part of the government's industrial strategy last year. And the sort of thesis behind it was that there's lots of end users across sectors. They don't know what technology is out there. They don't know how to use it. They don't know how to compare between the options. And so we've invited organisations to bid in to apply to run these hubs and essentially provide the expertise, some space for sort of demonstration, that kind of thing to help build the skills and understanding within end users so that they're able to feel comfortable investing in that technology. I think there is definitely a sort of element of the cultural within that, and I'm hoping this program can sort of help to turn that around as well. And alongside that, we've got the ARIA 57 million program into robotics flexibility and okay, moving away through some of the bottlenecks within that at the frontier end. There's various other competitions out through Innovate UK, lots of AI competitions have a robotics angle which you could bid into. There's a dual use drones competition out at the minute, and various other initiatives depending on what end user sector that you're interested in. So there's agri programs or programs in manufacturing. I'm very happy to link anyone up with the support that's available, and if you can speak to me after this. Outside R&D, there's also DCIT's Regulatory Innovation Office, so that's looking at how we can raise some of the sort of red tape that's stopping people from adopting these technologies, and how we can support either changes to regulation or improvements in standards and guidance to help people feel comfortable and safe using these technologies. They've got a website where anyone can go and put in their own ideas for any regulatory blockers, and they'll get back in touch and work through those with you. So please do have a look at that. The last thing I would highlight is our support from non-public financial institutions, so including the National Wealth Fund and the British Business Bank. they've already been investing into the robotics and autonomous systems companies, so including Wave and Oxa. So there's support available through that route as well. I'll stop there. There's very little bit, sort of
So yeah, if you want to participate in any funding, catch Caroline in the networking directory, sure for you here to the end.
Yeah.
Okay, excellent. Yeah. So jumping on over, what is your key piece of advice to anyone thinking of starting or scaling a robotics business within the UK or abroad as well? Mark, if you want to hit off.
Happy to, because what we just heard earlier, like talking to consultants and they come up with the technology and not a problem. I just want to second that and want to emphasize it because it's actually not as funny as a joke because everybody was laughing, obviously everybody is in a good mood, but it's really, really important. So, and that's really, we actually had to sit down, we had robots, we loved robots, but when we saw the new market in logistics, we had to ask ourselves, is it actually a robot that is needed or do we need something else? That's very, very important. So you have to understand the problem. Don't ask the customer first, but try to figure it yourself and then you come up with a solution. That's the most important bit, and I will bore you with that later when I present next week again, actually. So yeah, that's why.
Mark, perhaps?
Starting a company is pretty easy. You get the right people and you get together. Scaling a company in this country is pretty damn difficult. Getting the support, getting the money and so on. We've spent about 1.2 billion getting to where we are in terms of raising money. I think I'm a better fundraiser now than I'm a doctor, but you know, it's really expensive. One of my competitor American companies has spent 7 billion getting their robot to where it is, but it's not yet publicly available. So scaling in the UK is a real issue, and we all have to think about ways of influencing the country to release our pension funds, potentially give them more ability to invest in slightly riskier things, because we have great technology in this country. It's an incredible place and great brains, but scaling companies, I mean, I live in Cambridge. Most of the companies get bought by American strategics and taken abroad.
Okay.
Now, I'm not a pessimist, I promise. My name is actually optimistic, Obi. But if you're going to start a robotics company, i.e. a company that makes robots for some application in the UK, my advice to you would be don't do it. But I think something to look into maybe people like Mark, for example, with high margin, high value added products in terms of medical surgery, yeah, they can do that because they can get away with the margin, right? But until we reduce the energy costs in this country, until the government reduces that cost, you will never be able to compete with the Chinese, with the Turkish making these equipment. So you're better off going to a lower cost manufacturing place, making it and offering the service from the UK. That's the best model you might be able to get away with because it's just too expensive. Energy costs too high, too many regulations, right? And we're not adopting it here, right? So every macroeconomic factor is playing against you. You wouldn't do it, right? You would go somewhere cheaper and transfer service.
Having said that, we actually set our factory up in Ely, just outside Cambridge, because it's serves a area of high unemployment. And so that was to give, we believe in being a net positive company to give something back to the country. And that's what disappoints me when I don't see support. We've actually done everything possible to build a British company. And there'll probably be news coming about us in the next few days. I'm relieved to say it's not that we're being purchased by an American company.
And just for the answer, you don't start with production, right? So the costs that you can save later or not, they are not in the forefront when you're thinking. So like even us, we have a few robots, we can't even produce in China. So we are too few to actually start the production line. So I think there's something that the company can benefit from is like the whole knowledge and starting the engineering and the innovation. And then we need like engineers, expensive or not, who can quickly cycle, because you need this quick iterations when you want to go into a market, and that's everything is here. Specifically, that's or Caroline was just introducing the whole new development and funding hardware, which we didn't have 5-10 years ago. So that really goes best. I don't want to put a positive spin on that, I think.
Excellent, Caroline.
Sorry, can you just show? That's one.
Thanks. Yeah, it's definitely do so. The business advisor, I suppose the main thing we want to add is just to leverage the support that is available. There's a lot going on in the UK, whether that's in the private sector or in the public sector. We're not always the best at sharing out what's going on as well, but there's a lot of people that are out there that will be able to support you or want to work with you or want to collaborate. So yeah, please get out there and find those organisations.
So my last question, it's actually written down here as well. So we know that China is very, very good at hardware. So but what you said, the Chinese as well, with what they're thinking, perhaps companies should start kind of focusing on software, building the robots or buying the robots. Once you get up to volume, then you can start thinking about kind of producing your own and so on as well. Yeah. Do you think that this is a valid statement, Toby, that people should perhaps focus on software or even system integration?
100%. I think, that is the one thing I'm very positive on the UK. I grew up in Cambridge, Korea, so the amount of intellectual power in this country is unbelievable. Right? We got it, right? So if you take those strengths, right? Intellectual power, software, focus on that, focus on service, focus on integration. But that is not a defensible move, right? It's only a matter of time before Xiaomi, BYD catch up on software. We're not far away. So we are at an interesting crossroads, right? We need to service intellectual stuff will save this or will it increase it? Yes, it could be a way, but we really do need to look at things like energy costs, right? What is the difference between there and here? The government subsidizes their energy. Government doesn't subsidize yours, right? So why can't the government make energy for businesses cheaper, right? Pay the subsidy, whatever it is, just make it cheaper, right? And this is what we really unlock. So, and to answer the question, yes, British for the next maybe 5 years, 10 years, yeah, we can get away with intellectual stuff, service, integration. But it's not going to be that. The real business is full turnkey. Give me the hardware, give me the software, give me the service. That's what I'm paying for, and that's what I'll continue to pay for.
Or to you, Mark, question for you, but we see surgical robots. I haven't seen any Chinese surgical robot out here, but there might be some, yeah. But do you find the same competition from
The old Sunshine, you said, robots, hundreds now.
Oh, really? Okay.
They're all copies of the American system, Da Vinci. They're identical. They're what we call remote center motion robots, which is different from ours. If you look at a photograph of my robot in 2019, and you look at it now, it's identical. But that's where it ends. It's completely changed. So ours is a software-driven robot. We change the software every 6 months in response to what the surgeons tell us they're struggling with or want improved. So the software side, and we can do it in Cambridge because we've got such a might of software skill there and so on. But also in my field, there are other ways that you actually promote your sales. We have developed the best education program in the world, probably. So when the Royal College of Surgeons, which is the accrediting body of training, approaches me a week or two back to say, could I help them modernize their training? Because we use VR headsets and simulation and everything. One feels one's achieved something. And again, that's come from the might of educational strength in a country like the UK. And our research strategy, we've done using, I was a co-founder of a thing called Ideal. So we've done the research ethically, but far more affordably. And so they are, constantly got to be looking at what can you do to change. Don't be stuck in it. I mean, that's one of the downsides of having an ADHD head is every half an hour you want to do something differently. So there you are. But I mean, do it. It's worth it. This country has got real talent. Use it.
Mark, is there any final thoughts?
Just taking what I said earlier as the response, I think that production is the one thing. I'm not very hopeful on software that it will stay fast in that regard because it's also where it's a commodity, right? It can be very, very fast in integration. But the whole cycle, integrating, finding a problem, and building the mode, and I think it can be done here in the early phase, 100%. Yeah.
Caroline, any final thoughts before we
Thank
jump
you.
on questions?
Yeah, sure. So I think there is a bit more nuance as well on the hardware side. There is a report out from the University of Leeds called Why Does Nuclear Manufacturing Robotics that I definitely recommend having a look at. They identified around 100 companies that are manufacturing in the UK at the moment. And I think that while there might be lots of low-cost components coming in from China where it will be very hard to compete, that doesn't mean that there's no space for the UK to compete, or they can't be some high-value niches within the hardware space that where we could lead in. So I think, yeah, as well as software and desktop systems integration, there is more to think about on the hardware side as well.
Awesome. Let's take one or two questions from the audience. Quickly, I will run because I got very healthy.
Yeah. Thank you very much for the panel and interesting conversation. I want to ask about the perspective that the future, like the risk for building robotics company is quite high if you build something there's no demand even for that. So the challenge in the UK, I can see also in the investment field that the investors here are not taking enough risks for something that will be there in the next 3 years compared to the US, for example. What is your perspective on the ecosystem of investment for robotic startups within the UK?
Quick one. I'm not so much involved in investment currently, but I tried to find my company. It was pretty, very challenging. But Caroline is here to solve it. But what you mentioned earlier, building a robot, there's no demand. I didn't really understand that because that's not possible, right? So even if you see demand coming in 10 or 20 years, I don't see a chance that you start building it without having a very, very detailed vision of selling it. Otherwise, there won't be ever an investor putting money into that. So find a niche, have a vision, and start somehow smaller with something on the road where you can already embark on the pathway, so to say.
And you need a really credible story. I mean, in our Series D, I raised 660 million in a single round because we told them a story that actually was exciting and actually had real proof and benefits. I did it like I would have done a grant application when I was an academic, showed them what the problem was, showed them what the potential solution was, and then finding what the potential returns are. So even that requires real professionalism.
All right. I'll just keep it on that is, again, you really, it's a pay on margin, right? Say, Markson, for example, very high margin, high risk, high rewards sort of thing. In like the warehouses that, where it's very low margin, right? So capital flows where there's returns, right? So the investors really don't care about whether it's the UK or the US. It's like, what is that return going to be? So from their perspective, if they're going to get a bigger return on investment from the US, that's where capital will flow. If they get a bigger return on investment from Dubai, that's where capital will flow. I think we need to fix the actual problem. We're not adopting fast enough for a country with such a high labor cost, with high energy cost. Why? Fix that problem, capital will flow in like nothing. Because the volume is here, there's 60, 70 million people here, right? Until we fix those fundamentals, there isn't enough financial justification. I'm not a billionaire, but if I had $1 billion, I wouldn't touch it. Like, what am I going to get back in 3 years? What am I going to get back in 4 years? Versus putting that money in the US to work for me, but versus putting it in an ISA, right? You might just put it in an ISA and you will actually return more and actually build an company here, which is the crazy thing about this entire problem of trying to solve. Right? So that's my take. The capital will flow where the returns are just not showing here unless you have real high margin and real defensive modes. right? And medical applications, you can't touch it.
You've got to be careful of the margin argument. Just this month, Boston Scientific has halved its value, and one or two others have shed billions off their share price because the the investment industry is becoming suspicious that their margins are too high and that they're not necessarily producing the quality of what they claim they are. So my company, we believe in a thing of value-based medicine. We'd like to drop the margins. We're about a quarter of the cost of some of the other robots, and make your money by increasing the volume of sales and therefore give something back to the world. Because there are multiple geographies that do not get enough help, and it impairs economic development in these countries.
So I will stop the panel there. Sorry, we're running a bit over time already, and you're just getting warmed up, I feel. So if you have a bit more questions, feel free to drop them. I think Mark is leaving a bit early, and everyone else will stay here. And also, if you're getting to the stage where Mark is raising 600 million, you can probably talk to Hill Dickinson, they will help you out. So can everyone in Hill Dickinson stretch up their arm? So no, that's a few people there, so you know who to talk to if you're looking for fundraising and so on. So thanks a lot to the panel, big applause, thank you. Thank you. Now back for a bit more networking, back here in half an hour to hear the presentations as well. Thank you.
MPhil in the industrial system.
Okay.
Thank you, guys. Really, really love it. Thanks. Thanks, Caroline. Thanks, Marcus. Managed really well. Sorry, some of the questions were not agreed before, but it worked out well anyway.
I know it was agreed, but
I'm with your marketing team.
yeah. I know.
But you were okay anyway, yeah?
Okay.
You look okay. Yes. I was going to ask about German versus UK, but I thought that was a bit too simple.
I wouldn't know too much about that actually.
Perhaps you have some markers.
Hi.
How you doing?
Good.
Nice conversation. So, which products, which technology, I know it's a wrong question, does your company focus on? More in the logistics, right?
Oh, only the clothes.
Let's see. Brownie crown.
The person's to be the dog is to make sure the person is no, make sure the person is comfortable. Oh, okay. I remember that. Example. When we get to John, you're listening to you have no idea what you're
Another robotics is a very interesting and exciting topic. But now we're doing presentations now. So first up is Marcos from all three. Over to you.
Okay, so Tom gave us only 5 minutes, so I'm going to be starting as I walk in. I'll open with something very controversial for it's probably unknown a few of you around here tonight. If you have not ever seen, if you never saw a mushroom, could you imagine it? Robotics gave us the biggest gift of robotics. Where should I move it here? It's probably better. This is I don't know. Robotics gave us the biggest gift for freedom. We can design and invent what evolution never could. How is it possible that the best thing that we can do is to watch ourselves in the mirror and copy it? So, I'll get back to this in a few moments. So, building abstractions. I got very little time, so I'm going to go very fast now, guys. Building construction is one of the most unsafe industry on the planet, and is the one that has received the least R&D contribution than any other industry on the planet. You see the numbers about, the trends about productivity. You see what R&D does? Since 2000, that's the prices of houses going up, is the prices of TV going down. You got the gist. Now, why? How do we fully automate robotics? How do we fully automate building construction? The problem is that we are looking at automation innovation in isolation. These are the robots that we are deploying on construction site. These are single task robots. A robot that paint, a robot that put the tiles on, the robot that glues. How many robots of this you need to fully automate the construction site? Probably 100. Many of us are robotics, you understand what I'm saying, where the problems are. What if instead we look at automating, holistically approaching the end-to-end problem of construction? So, you build a plane. Now, the plane is amazing, but without the infrastructure, you got nothing. So if you innovate in one single domain and you don't think of the entire infrastructure around, before we have talking about scalability of our companies, this is a problem. So the Atlantis. I mean, it's good sound, but I can now mute it. Fantastic. Okay. So this is what we're building now. So this is our aircraft. Atlantis is designed to operate on the construction site, to fully automate every operation that happens on a rotary construction site. It's made. I need to go fast, guys. So repeat your imagination. This is how we plan to deploy the system. So we arrive with containers on the construction site. I'm sure it's a CGI, but you saw the robot in action, and all3.com, go on the website, you will see all the experiments, you will see all the videos of the live robot in action. 3 levels of modularity, you can change tools, the same robot can paint, can glue, can screw. Other robots go around with batteries, and swap the batteries so that you have an unlimited range of operation. The robots can both operate alone in collaboration, or they can operate with fully automated cranes.
we're going to be deploying these robots later this year on our first construction sites. So for our first pilot projects. So when at the beginning I said, we don't automate, we don't innovate on a single domain, but if we want to solve the problem of construction, we need to go vertical, we need to automate the full infrastructure. This is the aircraft, this is one element, but then we built and the infrastructure around. So all three we built what we call real-time architecture studio. This is a generative AI system that designs based on basically the layout of a building. It knows the laws and regulation of every country where we deploy. It knows the civil engineering laws. It knows the capabilities of our robots. So it enables really fast to design a building. Second element. So third element, component manufacturing. Everything that you design inside the RTA is sent to our factories. So our robots have a fully automated factory. Before we were talking about dark factories, so we build one here. Our robots can automatically build, fabricate everything that the systems, that the RTA Studio generates. Last bit, then the Mantis receives all the parts that are fabricated. So by intrinsically, everything that the system designs and fabricates can be handled by the Mantis. So if you have never seen mushrooms, could you imagine them? It's not a matter of mushrooms, you see them in reality on the field, but actually, the machine connects the trees all around, this infrastructure, guys. The secret to scalability of a company is finding a problem. Don't look yourself in the mirror and form of a function. Pick a problem, build infrastructure, function of a form, solve a problem. Money will come, you will stay in your company.
Thanks a lot for that. Well, time for one question, perhaps. Anyone willing to ask? Okay, there we go.
How does this deploy partially humanized, partially autonomous, or does it have to be a fully autonomous site?
Yes, so I repeat for who was there. So if I have currently the balance between human contribution, half automated and half not on the construction side, okay? So our objective is so we tend to full automation, of course. Now, the Mantis is not designed to work closely with humans, and this is the reason. Standardization and safety certification for human interaction takes a lot of time. We need to get to the construction site as soon as possible to find all the problems with the robots and so on. Also, our intention is not to half automate the construction site, it's to fully automate it. So there is no point in that. I'm trying to answer rapidly from different angles, right? So no need for human computer interaction, no need for human robot interaction, no need for certification. We go fast to the first construction site. Now, we go gradually. So at the beginning, we isolate one or two use cases, one or two operations that we are going to be performing end-to-end this year in full automation. This is required not just to validate the operation, but also to show to ourselves, to the investors, that we can manage the end-to-end process of deploying and shipping the robots across the board, getting the laws and regulation, the decimal and nitrogen regulation, all these things. Once all this is done, all this information go into the next generation of our robots. We saw that is the second, the third generation is going to come next year, and that's the generation that generates the ROI dramatically for the company, right? Did I answer? I try and expand from multiple angles. Yeah?
Excellent. So, there we go.
More questions in the networking break. Yeah. Thank you. Thanks.
Thank you, guys.
So we have come to the slide. If I pronounce that right. Yeah, Recycling. Everyone always gets it wrong.
Hi guys, I'm Martin from Recycling. Some of you might have heard of us, but I'm going to give a quick whiz through of the last few years, and I hope you find that interesting. I've been at Recycling for 5 years. I think the company's been going for 6.5 years. So I've kind of seen it from when both of our projects, actually, all three of our products were babies, and now they're all quite mature. And these are some of our robots. I should have had my name on there somewhere. I'm also going to whiz through. We've got machine vision systems. They're used by themselves for insights, for solving problems in the plant. The robotic product uses a vision system as well, that's pick and place. And the optical sorter is like an industrial sorting machine that uses the vision system as well. So a bit of context, we operate in the waste sorting industry. So that started in the curbside dry mix recycling, and now it's expanding into lots of industries. There's at the start a massive mechanical sort for size and density. In the middle, there's an optical sort, which we all love, and the industry loves as well because it's the most trusted sorting method. And at the end, there's a manual sort, which at the moment is all human pickers, and we are kind of introducing robots there as well. So what is the existing state? There is lots of manual picking. We know the problems with kind of dangerous sites and humans getting involved in rubbish. There's old machinery, there's high maintenance. There's also lots of recycling plants burning down, which is really, really sad. Especially one of our clients this week, which is awful. Why robots? This is a kind of tale as old as time. Our robots will obviously do 3 shifts a day. They're fast. There's huge labour problems in the plants, they're really horrible places to be. And it's going really well. Some of our robots have been picking for 4 years. One in Reading's been going for ages. Fast pick rate. I can speak to anyone about pick and place robots. They're doing really well, and I've worked on these for for a while. This is an awful gift that's come from a video, but my one huge piece of advice is get IP cameras that are placed in a regular position so that someone can do your customer support really easily, because otherwise it grinds the R&D to a halt. This is our other main product, optical sorters, and these are really, really cool. These in industry are very trusted, but they usually use a near-infrared camera, and we are doing it with a typical vision system. This, as I was saying, we're going into other industries. This is brick being sorted from concrete. This is normally 4.5 meters per second, but it's very slowed down. So inside one of these capture heads is absolute chaos. You might have seen these with like rice or food sorters. They're really cool. So these are all the things that we can do with an optical sorter. The robot is currently a little bit more specific. It's all kind of the waste sorting, but it's doing well. So until about a year ago, we were using our partner's ejection equipment, our vision system, and we decided to build everything in-house. We're also building in East London, so we got building in the UK. These, everything is being built by us, and everything was started design about a year ago, and we've already got it all industrialised, and 4 of them have been installed in Scotland. I was there last week installing them. So we decided to break ties with the American partner and say we're going to finish it ourselves, but then that did lead to the American company buying us, and we have now merged. So sorry. Just to say, they're really well-done products, and they're competing with Tom and FedEx near infrared solutions. We're now together, which is actually really cool because CP Group do the whole plant, which you can kind of see in the background. We do the machines, and their subsidiary MSS also do machines, and they've been doing for 50 years, so it's going to be a really cool partnership. These are some of the tech that go into it. This is a barrel block positioning system that moves it down and back up to unblock stuff. This is a machine learning model which follows the linear, so that can see when somebody's working, when it's not. This is another patented. There's another patented spiral shield that is a bit like a sump, which connects, also protects it from dust. Quick plug, we're hiring engineers, so we're hardware, software, or machine learning engineers, or these 2 aren't announced, so just go to the website in about a week. That's pretty much it. There's nothing to speak about, but that's me. Anyone, one question again?
I wish out, how many years can we fully automate, and what do you see as the most challenging part?
So, I've got some unused slides. We're actually looking to automate fully the whole plant. So that's one of the things that our new parent company wants us to do. So whether it's care, insights. These are things we already do. But if you put vision systems absolutely everywhere, this is an industry you can actually kind of fully automate probably quite soon. So I don't know if I'm going to put a number on it. Maybe.
Go on.
I think you could do like 90% of it within 5 years, but the last 10% will be really difficult. But that's a lot of investment, so we'll see. It depends if you look at robotics in America have got $200 million rounds, so they have tried, so it's been done.
Not investment advice, by the way.
Yeah, it's a big round, yeah.
Thanks a lot for that. Big applause again. So, Neurocore.
Hello, yeah, good evening. My name is Steve James. I'm the CEO and founder of Neurocore, and I'm also assistant professor at Imperial College London, where I have a research group in same sort of stuff, end-to-end robotics. So actually, before we go to the next slide, I kind of want to define what I mean by physical AI, and I think the best way to think about this is to split it right down the middle. And I like to think about it as robotics 1.0 and robotics 2.0. And you know, what do I mean when I say that? Well, I'm talking about the gradual shift away from programming and modeling these individual components that you see here in a classical robotic system, usually robot manipulation, and actually instead moving towards an idea of robotics 2.0 state-driven. Right? So instead of actually having each of these components, you're going to be instead sending data in. It doesn't matter whether you're kind of picking strawberries in a field or whether you are kind of folding laundry in a hotel room. Right? The idea is that this module here is actually the same, that doesn't change. So that's what I mean. And there's two kind of great things that can come from robotics 2.0. The first is that it can actually allow the stuff that we already do with robotics 1.0 to happen faster. Right? There's a great report by the Boston Consultancy Group that's looked at the system integrators and found that around about 75% of the code that was written for each project ended up getting thrown away and then having to be rewritten for each of the individual projects that comes in. So that's one great thing that can come from robotics 2.0. And secondly, it enables next-gen applications. So maybe things that couldn't have been done before, but now can be with this new technology that allows you to actually learn. Right? You're not like telling the robot what to do. You're showing the robot what to do, and it's learning. So robotics solved, right? Well, not quite. Bringing a robot to market is still really, really difficult, and there's a whole host of problems you have to solve. We've got the pre-deployment stage at the bottom of the Jenkins stack here. Things like, what is my robot going to look like? What's the robot design going to be? Then above this middle section, which we'll come back to in a minute, you've got post-deployments, How am I actually going to integrate this into the factory floor or the home? What's the kind of reliability and success metrics that I'm after? How am I going to manage the regularization and the legal aspect? But what we can now do with robotics 2.0 is actually start to standardize this middle part, right? Which I like to call the infrastructure layer, right? It's the bit that actually doesn't change between each robot. And that's exactly what Neurocore tries to solve, right? It is a enterprise flywheel for robotics 2.0 that allows businesses to be able to employ this technology as quickly as possible and actually focus on the things that is most important for them, rather than actually have to build this flywheel themselves. And what does this flywheel actually look like? Well, it's usually consistent of four main things. The first is the ability to collect this data, because remember, we're no longer now programming these robots, we're teaching them. So you have to collect demonstrations about how to actually do the task that we care about. Then curation and understanding. How do I actually take this data that I now collected, and how do I choose what I'm going to actually shove into my model? And what other data are I also shove into the model as well, right? So we've had help with that. And annotation, annotate rewards, maybe some language commands, etc. Training. How do we actually then choose what model we're going to choose? Are we going to use state-of-the-art vision language action model? Or are we going to use something that's only 50,000 parameters, which actually can solve a lot of the problems today? And then finally deploy it. So once you actually train that model, how do you then get that running in the cloud and streaming the actions that are coming directly from that model? And again, this is basically saying the same thing. So you can imagine a situation where you've got some robots, you've got some talent operation system going on. So here we've got Mark with a dual system. He's then collected a data set, which he's then visualizing, and can actually synchronize this data and be like, okay, what happens if I train my policy at 5 bits? What happens if I train my policy at 50 bits? What's that actually look like? What's my network going to see? Training, so actually be able to train on that data set that you've collected, or actually train on a much larger data set with, say, 10 different robots and do something what we call cross-embodiment training, right? How can we start to generalize across all of these robots? And then finally, deployment. Oops. Cool. Horrible text. I'll skip this in terms of time. I think a big thing here is that a lot of our code is actually open source. So we're very, very big into the open source community. Obviously, because my academic background is a big part of the company as well. And so, we actually have a free tier for academia, which they can jump on and get quite a lot of usage. And then obviously you have a range of different plans for all different types of customers. Thank you.
Excellent, thank you. Thank you, Paul. Good question, yeah.
Why is it called physics? Does it have a physics model built into it?
Physical AI.
Yeah.
It's just the general category, I would say.
Okay. Yeah. But it understands physics?
Yeah, it's about taking a lot of the AI that we're seeing today and actually getting it working in the physical world. So it's trying to differentiate maybe between, say, language models and vision language models. And actually, how do we get these things to start working on?
But does it understand like aerodynamics and problems?
No. It's just purely about taking AI and putting it onto a physical platform.
Awesome. Any more questions, please reach out to him during the networking break. Yeah. Thanks a lot. With that, we welcome next story back on.
5 minutes. Okay, cool. So I used to have a title, but then I couldn't decide because I actually present two things. First of all, I present the company so that you all know what we are doing and how cool we are. And the second part is give you a bit of a secret sauce of how we scale and what our secret is, so to say. It's not really a secret. I made many talks about it already, but maybe you haven't seen them yet. First of all, Textory. So we are around since 2015, and essentially what we are doing is we have all these customers and many more, and we offer them the full visibility of their warehouse so that they don't have to ever search their stuff again. And when we ideated about that, it's actually quite surprising how much stuff gets lost. And yeah, we solve this, and the robot actually is only the tool, means to an end there, so the customer buys the data, and we deploy a robot for us to collect this data, which is the exciting part for me, because it comes with a lot of problem. You cannot just ship a robot and run away, but you actually have to take care that it's maintainable and reliable, etc. So all the cool things you like to work on. That's where we are, and that kind of leads into the secret idea, actually. So that's where we are deployed now. A few sites are missing, but you get the gist. So kind of all over the world. Actually, I'm wondering if it's complete, but imagine some more dots. Okay. Here our storyline, so found it, and actually that's my favorite robot. And it had a lot of cool features, but it essentially was also bumping into things. And we couldn't do this anymore. We designed and had a customer who told us, hey, there are warehouses and you actually have to, there's a use case for you. And so like, well, let's put NIMs there, and NIM is only like 2 meters tall. Ended up to be almost 3 meters. We had tall NIM, and then we realized we need something way taller. Or drones. And actually we ended up like, no, it doesn't make sense. We want to have this robot because we can be faster, safer, and scan thousands of locations, 10,000 locations in an hour. You see our funding, and the cool bit we are quite proud of is 2022, we ideated, we saw the new use case, we designed the new part. I also designed a tiny little new sketch of the robot, and from the sketch to the first deployment, it took us 6 months actually. First sketch to customer 6 months, despite this crazily tall robot. And now we have a new robot, and I have to jump here. Oh, no, the video is not working. So what is the robot doing? We have this 1.7 tons heavy, 80-meter tall, that has tons of lidars. And as I mentioned already, we are robotic as a service company, so which is fun. And we operate in active and dynamic warehouses. All we need is a socket. We never change the environment, which is also cool. That's why I work there. And we are scanning in warehouses like 250,000 square meters and 200-meter long aisles. It's pretty insane. Sometimes I drive around in the buggy in these warehouses. How do we do that? Open source, as a gentleman, yes, okay. So we leverage a lot on open source. We not be in Elsevier, we not just delivering it, but we supporting it. So you will see a lot of contributions from us in ROS2, or like here's the Robotech plugin for lidars, didn't work for us, so we funded the whole development. We funded a lot on the navigation 2 stack as well. You can see, obviously, some tiny companies also funded, and then there's us. So keep this KPX model in mind. In 10 years, it's actually replicable. So, and then we have ROS2 now, STIQ. So why open source? I can just recommend it, it makes you fast. And you have a huge community who's actually testing what you're doing. Because if you had all people for yourself, you need a lot of people for testing it. Throwing it out, people will tell you off immediately. So that's great. So we don't have too many people to do it. That's one of our scaling secrets. How much time do we have? Oh. Let's say 2 minutes. Yeah. Okay. So yes, that's the one. And then the bigger part here. So this is actually part of a whole keynote I gave 2 years ago and a year ago again. So it's all very condensed, right? So I will try to just get the key learnings and try to convince you that it's very important. So from the scaling has many, many facets, right? Business, engineering, etc. From the autonomy side and from the engineering side. I can just really try to get this bit away that keep it completely minimal. So where I came from, locally and from my mindset, we used to over-engineer a lot of things, especially also in academia, because you can foresee already, what happens if this thing and this, and maybe the customer needs it, and you end up in the end, there's over-engineering cycle. So what we've done instead with the 6 months, and I learned this as well from my founders, is like, well, let's not do that. Let's build the most crazy minimal solution and chuck it to the customer. Safe, of course. And that's what we've done. And all our hypotheses we had, how we could scale from there, kind of went under the water because we learned, oh, the customer actually needs this. The customer wants this, the customer has a problem here, and we could go back to the drawing board and iterate on our development. And that's all what we are doing constantly. So we have hypothesis, we put it out, we prove it wrong or we prove it right, and then we iterate further. And we deploy code every 2 weeks to our whole fleet of robots. And that generates a fast feedback loop. And obviously, you have to test a lot. If you do this every 2 weeks, which we have, you have a massive testing engine. And for all the engineers out there, my tip and piece of advice is never call it testing. Nobody will give you time. Nobody will fund you for that. Just call it time to market decrease. And then people will be like, wow, that's a great idea. Let's do that. And secretly it's testing. But all the investors not listening, just for the engineers here. Okay. I leave it there, but okay, you see me talk, great stuff, more tooling, lots of tooling if you need to know this. And we are also hiring, and we have our talent team here. You have to stand up, guys, otherwise. Ta-da! So if you have any questions and need to roll, approach them. Cheers.
Awesome. Thanks a lot for that. So, 1 or 2 questions. Yeah, okay.
Right, okay. I've actually had a lot of experience with exterior robotics.
Oh. Okay, not to put you on the spot, Pete, but one of the blockers that I faced actually rolling out at Dexter was this. So we have put the robot in our warehouse in DHL Coventry. You probably know the one I'm talking about. Okay, cool. Yeah, and the ID logistics was in France, right? So we have put it there, and
it's meant to basically help you with audits, right? Stock check and your inventory checks. So our insurers, for example, in our contract with our insurers, say it has to be a human doing the check, right? That's how we were sure that like it was checked. But with the Dextery solution, it's a camera, right? And that's not only, yeah, indeed, right? So it's a camera and systems, right? So it's just not a human. So how do you get over that? Where you then have, these little blockers, for example, really annoying, right? That basically say, look, it's a human that's meant to do it versus the Dextery system that's meant to do the checking.
I forgot the term now, but there's some licensing OS3 or something. But I forgot it. But we have that, and we are legally allowed to do the inventory for most countries. And then you can just use it and don't need a human. I'm not sure if it's the same in France, to be fair. So like this part of business development is, I don't have time for this, unfortunately. But I will check it up and send you, but there's a license.
Okay, the next story will be around later, and obviously one of our treasure sponsor of this event, so big applause again. With that, over to James from, he'll take us on just to give 2 minutes, and he will tell you from the piece up to you.
So, yeah, absolutely. Look, I'm going to keep it short because, as Tom said, I'm anything between you guys, pizza and more wine. So, I'm going to say 3 things very, very quickly. First, Tom, wow, every single time, this is the 5th time that you held this event here. Repeat attendees, superb presenters, the chair, okay, but at least your panel's been fantastic. So well done, Tom, fantastic. And second thing I'm going to say is we're a law firm. For those who didn't know, there are some people who don't know that. We are a law firm, full service law firm, comes through us, fundraising, employment issues, contractual issues, commercial contracts. Gary, I pre-warned him, Gary over there, he's got his hand in the air, will say 2 seconds worth of what Gary does day in, day out. Gary?
Hi everyone, hopefully you can hear me okay. So I'm not a funding type lawyer or a corporate lawyer. Rachel and I, we're technology and commercial lawyers. So what we actually do is help people like yourselves in 2 ways. On one side, in terms of the development of your products and services, we help with arrangements between possibly you and people who assist you with bringing your products, creating your products. So we'll assist on the IP side, software side, development side. And then on the customer side, we can help you commercialize your products and get it to market. So we'll deal with the contracts with your customers, distribution arrangements, resellers, etc. So we cover the full sort of spectrum in terms of the commercial arrangements. And I think we're quite important. So yeah, there you go, James.
Absolutely. Thank you, Gary. That was brilliant. So I had someone earlier I was speaking with who just said to me, God, we might, we've done everything we need to do. Just can't get a contract in place. Yeah, bloody lawyers. Anyway, enjoy a beer, enjoy a pizza, wine. Thank you, Tom.
Yep, thanks all to the audience. Now go quickly, that's limited pizza. Run.